Welcome back. Today we will begin our conversation about what are known as factor markets. And we'll begin by defining what the factors of production are, and we'll look at how the demand for these different factors is derived, how to graph it, and we'll talk about calculating the profit maximizing hiring decision when it comes to using these different factors. And so we start by going back to the beginning, back to the circular flow diagram that we looked at back in Unit 1. And that circular flow diagram showed us that there were two different types of markets, the goods and services market and the factors of production market. The goods market is what we've just finished studying so far this course. We've looked at monopoly and perfect competition and oligopoly and monopolistic competition. But then there's this other market, the factor market. Firms receive access to the factors of production in order to produce the goods and services that consumers purchase. And so what we're focused on now are those various factors of production. And those factors of production are land, labor, capital, and entrepreneurship. Land is going to be any sort of natural resources, not just the physical land, but any natural resources that come from the land. Labor will be the work done by people. And then capital is typically going to be the tools used in the production of goods and services. And we break capital down into physical capital, which are the physical tools and machines, and human capital, which is the skills and knowledge and training that individuals have in order to do their job. Finally, we have entrepreneurship as the final factor of production. That is those people who have a talent for taking risk. Entrepreneurship is extraordinarily important. Without it, there is no creation of new goods and services. All four of these factors of production are extraordinarily important. There will be a market for three of them, land, labor, and capital. These factors of production will be sold in the factor market, and the price that is charged for land, labor, and capital are known as the factor prices. These prices are set by market forces, by supply and demand. And the factor prices are very important because it helps us identify how to allocate scarce resources across the market. So for example, we might say that nursing is a hot new career. And what we mean by that is that there are a lot of new jobs being driven or created because there's a huge need for nursing care. And those jobs come with attractive wages. And because those wages are attractive, because there is an abundant number of jobs in that field, we begin to see people begin to take courses in nursing so that they can enter into the field and take advantage of those higher wages. No one had to tell people to become a nurse, but the factor price incentivized people to become nurses rather than history teachers or whatever other option they may have had. And so what we can say is that the demand for these various factors of production is derived from the demand for the goods that go with them. So factor demand is derived. That is, we need workers because we need the goods that people want. We need people who can manufacture electric vehicles because there is a demand for electric vehicles. Or another example, let's pretend that a report connects coffee drinking with improved cancer outcomes. The more coffee you drink, the less likely it is that you're going to get cancer. So what would happen then to the price of coffee if that were the case? Well, we would expect the demand for coffee to increase. We would expect the price of coffee to rise and be more profitable to make coffee. As a result of that, we will need more coffee bean pickers. The demand for people to get the beans from the plant will be greater than it was before because the product they're producing is more valuable than it was before. You can't have demand for coffee bean pickers without demand for the product they're producing, without demand for coffee. The amount of each factor that I need or demand for my business is driven based on the marginal revenue product created by each of those factors of production. The marginal revenue product is sometimes also called the value of the marginal product. And what it's measuring is how much money is being generated by each factor of production. It's calculating the value of their work. So you take the price of the good they're producing and multiply it by their marginal product. You're multiplying the price of the good by the number of goods that each subsequent factor production is adding to our total production. And as long as this marginal revenue product, the value of the work that they're creating, is more valuable than what they cost, I'll be willing to hire that factor of production. So imagine I'm running a lemonade stand where I'm charging $2 for a glass of lemonade, and I'm hiring workers at a price of $8 per worker for the day. So we look at how much total product there is. The first worker creates 8 cups of lemonade, so his marginal product, the change in total product over the change in output, is 8. The second worker comes in, and with 2 workers I can produce 18 cups of lemonade. The first worker added 8, which means the second worker added 10. The third worker comes in. We have 26 total cups of lemonade. We had 18 before the third worker. Now we have 26. So that third worker has added 8 cups of lemonade. The change in the total output when we added one more worker was 8. So that's their marginal product. Each worker produces cups of lemonade that sell for $2 a piece. So that first worker is adding $16 in revenue to the company. He produced 8 cups of lemonade. We charge $2 a piece. So his work is worth $16 for the day. The second worker's marginal revenue product was $20 because he produced 10 cups of lemonade at $2 per cup. Means he's worth 20. The third worker is worth 16. We could work through the same process for the remaining workers, seeing that the fourth worker's marginal product was 6. The fifth was 4, and the sixth was 2, which means that their marginal revenue product for the fourth worker was $12. That's the value he's creating. The fifth worker's value was $8, and the sixth was 4. My decision on how many workers to hire then is based on marginal thinking. Does the worker's marginal benefit equal his marginal cost? Is it greater than his marginal cost, or is it less than his marginal cost? So that general concept of optimal decision making, which we've used in the past, is also used here. In this case, I will continue to hire workers as long as their marginal revenue product, which is their marginal benefit to the company, is greater than their wage, which is the marginal cost. And I'll keep hiring workers whose marginal revenue product is greater than their wage until I get to the last worker whose marginal revenue product will be equal to his wage. I would never hire somebody whose marginal revenue product is less than wage. I would never pay $15 to get $10 worth of work out of somebody because that leaves me worse off than before. So if I go back to my lemonade stand, I can see that the first worker is definitely worth it. I would definitely be happy to pay $8 to get $16 in exchange. And I would hire the second worker because I would pay $8 to get $20. I'd hire the third, the fourth, and the fifth. I would not hire my sixth worker because, as nice a person as he may be, he's costing me $8 and only generating $4 in revenue. So if I'm looking to maximize my profit, I would never hire that sixth worker because he leaves me worse off than before. We could work through another example. Let's pretend that James and Dolly run a sewing business and that they charge $20 for each sewing job and that they have to pay $2 a day for each worker that they hire. So we could have a table like this in which we have the total product and we'd have to calculate marginal revenue product. And if we did the math and worked this out, we'd see that the first worker adds 18 units of total product, and the second worker is adding 16, 14, and so on. To find their marginal revenue product, how much they're worth, again, I take their marginal product and multiply it by the price of the good. The first worker is adding 18 sewing jobs, and each job sells for $20 a piece. So that first worker is adding $360 to my total revenue. And then I could work through the math again, and I could see these numbers. I could then graph the marginal revenue product on a graph using the vertical axis is money, which is showing us both the wage rate and the marginal revenue product. And the horizontal will be the quantity of labor that I'm hiring. And I can see that if the wage is $200 per worker, that the optimal output would be 5 workers because it's the fifth worker, that is the last person who is producing at least as much value to the company in terms of revenue as he costs to hire. Every worker before the fifth worker was producing work that was valued at more than $200. The fifth worker is producing work that's valued at exactly $200. And the sixth worker and on down is producing work that's wonderful, but it doesn't bring in as much revenue as it costs to hire them. So as the wage goes up, the quantity demanded decreases. If the wage were to fall, the quantity demanded would increase. Now, this concept should sound awfully familiar to you because that is the same concept that we used when looking at the law of demand. And so it turns out that the marginal revenue product is the demand curve for each of the factors of production. Because it's a demand curve, it also has our good friend shift versus movement show up again. When there's a change in the wage for labor or a change in the price of land or capital, then we see a movement along the existing demand curve. If there is another change, it's a shift in that demand curve. The nice thing about having derived demand is that any time you see a change in the marginal revenue product that each worker is generating, it's a shift. It's that simple. If the marginal revenue product is changing for each of the workers, we've seen a shift. If the marginal revenue product is staying the same and there's a change in the market, it's a movement along the demand curve. Now, why are we going to see a shift? Either because the price of goods changes, which increases or decreases the marginal revenue product of the worker, or because there's a change in the supply of other factors of production, or because there's a change in our technology. A change in price, that's going to be a shift. If the price of a good goes from $20 to $25, if the sewing job for Dolly and James goes from $20 a piece to $25, then you can see that the fifth worker is generating not $200 worth of value, but he's producing more than $200 worth of value with that higher price. That sixth worker was producing value, but not as much as he cost, or he was producing less than $200 in revenue for the company. But now that the price of the good has come up, that sixth worker's work is now valued at $200. So if the wage is still $200 per worker, now we've seen an increase in the quantity of labor because there is an increase or a shift in demand. As the wage stayed the same and now I want more workers, that's an indication of a shift. There could be changes in the supply of various factors of production as well. For example, if I increase the physical capital available to James and Dolly, if they have more sewing machines than before, then that could lead to an increase in productivity of workers, which would cause each worker to be producing more items, which gives them then more value for the work they're producing, which would be an increase in the marginal revenue product or a shift in demand. Or if I took away sewing machines for some reason, then that would reduce the availability of various factors of production, which would reduce our productivity. That would make each worker less valuable than before and cause a left shift in the marginal revenue product or the demand curve for that factor. Changes in technology can also help. If we improve the technology that we have available, if we give better sewing machines, then that can increase productivity. So instead of hand-cranked sewing machines, maybe there's an electric pedal that enables each worker to produce more goods. Again, if there are more productive workers, if they're producing more items than before, that raises the marginal revenue product of each worker. They're bringing in more revenue for the work that they do. And that would then create a right shift in the demand for labor because the marginal revenue product is increasing for each of those workers. So it turns out that changes in technology and improvements in technology, even just the introduction of technology, can oftentimes add jobs to the economy. It's not that technology takes away jobs, it creates different jobs through a process called creative destruction. But it's not going to take away the total number of jobs. It may shift where these jobs are being located and the type of work that's being done, but it will lead to an increase in the demand for labor overall. We'll talk more next time about the market for labor specifically, and I will talk to you then.